All right. Hi, everyone. Welcome to our second Bombay Julia Meetup. My name is Shikhar Mishra, and I'll be your first host this evening for Surveys with Julia and the soft introduction to Survey.jl. So what is survey analysis or complex survey analysis? I'm sure you would have heard about censuses, and surveys are often contrasted with censuses, which are a 100% survey. They're a very important empirical tool for social and behavioral sciences and experimental sciences. And the idea is that we have limited amount of time and money in order to be able to build a picture of a certain target population. It can be the population of a country. It can be the population of a city or a district, or your hospital staff or emergency workers. It can be any such population. And the goal is we want to observe a small set of individuals in that population and try to extrapolate based on, let's say, 1 or 2% of the people, what the picture is in 100% of the population. And there are lots of techniques for increasing precision as well as the representation of a survey. For the purposes of this talk, we'll focus more on the Julia aspect. But I just wanted to let you know there are lots of types of survey designs and sampling methods which can be applicable in different scenarios and cases. On the right, I have, for example, from I think this is the Australian census. There's a question about what's your income, and then you can choose a box where you fit. Some light survey terminology. We care a lot about how much one individual in our survey represents in the population. So, quick example, you have 1,000 people in your population. I surveyed 10 people. So a naive weighting factor would be 10, that each of my 100 people, they represent 10 people in my full population. There's another concept about strata and stratification. So think of these as subgroups of a population that we know a priori or before we conduct a survey. So we can know people's gender, where they live, their addresses, what's their education level sometimes. And if we use this information before designing a survey, we can improve the representation. Another thing that is quite common is we have logistical constraints. We cannot go to every single place and every single geographic distribution, generally speaking. So you often find clusters of targeted surveys. So maybe I might go to Andheri and I might go to another suburb in Mumbai, but not all of the suburbs. So what does a survey analysis package actually do, and why do we need one? The short answer is that the summary statistics from a survey, they're not the naive arithmetic. For example, if you want a population mean of a given variable, let's say height or income or gender, it's not just as a simple base.mean Julia method on a numeric vector. There are some corrections and weighting factors you have to apply in order to get a true population mean. Generally speaking, point estimation is relatively easy, but variance estimation is where the majority of the computation and real time of the package is spent, and it's you need quite a lot of complex computation routines for those. So what a survey package essentially does is that it exposes an intuitive API to the user and automatically applies a lot of these corrections and formulae in the background. For example, in the Survey.jl package, you can do mean of a variable on the data set, and it gives you what you would expect it to do. And yeah. So it's brief about our engineering journey so far. At XKDR, we were net users of the R survey package, which is the benchmark for open source survey analysis. There are paid options, SAS and Stata and those things, but in terms of completeness and open source, R is the benchmark, and we internally used it for analyzing lots of CMI data products and surveys, such as the Consumer Pyramids and Household Survey, National Family Health Survey, and among others. But the main challenge there is that it was designed in the early 2000s and with megabytes of data in mind, not gigabytes of high frequency data that we see coming in over the last 5-10 years. So it can be substantially slow for large and bigger data sets, and also for many classes of simulation problems. For example, you might want to do variance estimation using bootstrapping, which is relatively common, and sometimes you would face like 4 to 5 hours just to find a similar summary statistic and its corresponding confidence interval. So sometimes it's just not acceptable, and real world performance was one of the key factors while we developed Survey.jl. Just quickly, why Julia for complex survey analysis? And I've summarized it in 4 high-level points. But first of all, we talked about performance. You can combine the expressivity and the verbosity of R and Python, and with the speed of a systems programming language.
Are there aspects of Julia where we can improve the API design compared to the R survey?
Definitely. And internally, we can verify that as well, like moving some of the previously written R survey code into Julia, porting that across. Just a simple line-by-line translation speeds up the workflow of survey researchers.
I'm on a black box user.
Okay.
That things like multiple dispatch have cleaned out the API design of many things.
Yes.
Are there those kinds of opportunities here?
Yes. So, for example, modularity is one thing. R and a lot of packages, they are closed designed, and suppose you want something custom. You want a custom replicate function, because I'm sure you would love those things, right? So we build the API with keeping in mind that, okay, we'll give you some basic features, but if you want to add on something that you've customly written, you can put it on top and it works nice and easily. Whereas that might not be the case for a tightly knit system such as in R or Python. The other thing I kind of touched there, but not quite, was in Julia, we can avoid the 2-language problem. That is, the speed in many fast frameworks in R and Python comes from C or C++ or Fortran, God forbid. And developing those and maintaining those, it's much easier in Julia. And most survey researchers just want something that works great out of the box. The other thing was community support. So there were several discourse posts and even previous unmaterialized attempts at creating a survey analysis package. And we even received some feedback and contributing PRs from some of the previous users and who were interested in a package in the Julia ecosystem. Speaking of which, Julia now has substantial statistical computing abilities and several optimization and probabilistic programming and neural network packages. They are state of the art with respect to a lot of other languages. So survey is a complement to and complemented by the entire ecosystem. So what does Survey.jl provide? An efficient computing framework for all of your survey analysis needs. We started off building simple, most common things that one would require, like your mean, total, ratio, and quantile functions. Then many times we want estimation within segments of the data set. So like your states and by districts and grouping by. So we have support for that. Currently we have variance estimation using bootstrap methods. And just to give you a quick, brief difference between the speed, like you can do 1000 MC simulations in Julia in the same time. R can do 50. So there's a lot of speed up gains as well. Next thing is modularity, and you can write your own custom weighting algorithm, and we have a wrapper that you can easily augment the package as you would like to see fit. We also have basic support for wrappers for visualization. And we've tested and compared the correctness of our implemented algorithms against the R survey package, which has been developed for almost 20 years. So,
Shikhar, out of everything that you said so far, the modularity is the customizability.
yes.
This is the thing that I understood. So
Okay.
I'm presuming or hoping that towards the end, when you have examples,
Yep.
you want to elaborate on that.
Yep. I have 2-3 slides down where I can explain you that concept much better. So at this point, I'm going to go to GitHub and the documentation page to start a small demo. So this is our GitHub page. You can land here. We've got some basic examples on how to go about constructing a survey design and what are some of the cool features that you can do with them. You can have a look at this, but in this documentation page, we have a small tutorial that we can get started. So you can get started by adding survey to your Julia REPL. Then you can do using survey. Here we load a TOEIC survey data set. It's about high school students and their...
When you say load, how does it discover the survey design?
Right now,
find out the weights and all that?
So right now it does not know at this stage. We have just loaded it as a simple data frame.jl.
I thought there was some magic.
The magic starts now. So this is like 40 columns that you get in this. So this is where the magic starts. Suppose this is where you tell the package that I want a survey design using this data frame, and this column is the weighting factors, and it will prompt you and tell you, okay, these are your population sizes and sample sizes and weighting factors. And further down the line, I'll also show you the next example would be where you have stratification and clustering present in your data set. In this particular data set, we don't have those. So for, like I mentioned before, you can take mean of the 90th percentile of API scores or something like that, and it'll return you a value. Now, like I was talking about bootstrapping, you can pass your created survey design object and specify the number of simulations you want to find your variance. So this object now gives you a replicate design. And note the two key things.
So, can I understand? You don't do any analytical standardizations, you only simulate standardization.
We have a PR for, so there is no accepted generalized analytical solutions. They do exist, and we have been programming that, and there is a PR. And very soon you should be able to get the closest Taylor series approximated.
Treating me as a dumb user,
yes.
You would say you're always better off simulating.
In many cases, yes. In many modern survey data sets, you only get replicate weights. So you cannot do, if you have a very complex folding structure to your survey, yes, you probably better off doing simulations.
Or just as a sideshow, maybe we need a blog article
yes.
on what are appropriate number of simulations for convergence in CMIC pages. So at some point, you guys need a guidance page on each of the survey data sets of the world. And inside that, one of the elements should be the simulation study on how many Monte Carlo simulations are appropriate for getting some standard survey tasks.
So just to give you for reference, this parameter by default, if you don't supply it, is 4,000 simulations. R, the default is 40. So, and R fails and takes hours many times based on that number of 40. So,
sorry to stop
yes.
you, but we have just 2 minutes.
Yes, okay. So let's just, and then you can pass vectors and get other kinds of summary statistics. And here's also a simple plot, and there's, let me just quickly give you a demo workflow using the CMIE CP HS dataset, which is one of the best multi-stage stratified high frequency surveys for Indian households. In this slide, we import, there's some code to connecting to your SQL database. You would generally in this workflow, you would run an SQL query, and that the output of that query, you will dump it into a data frame object. Then you would create a survey design like I specified, and here we know the clustering and strata arguments, so we specify those as keyword arguments. Then what you can also do, then you can continue using these for summary statistics. You can also create a bootstrapping replicate design. The key difference here is that now you have 500 simulations appended on cbinded to the side. So there was only 17 columns before. Now you have made 500 simulations where, you know, sometimes a certain object is there or a certain observation is not there. And those are used for your calculating your variance. And observe how there's replicates 500 now. And then you can continue to find summary statistics like mean on the overall India, or for example, you can separate them by districts for subpopulation estimation. If you specify 2 arguments, the second argument is what you want to group by over. So you can observe now you have statistics for all the 97 homogeneous regions. We have lots of plans. Some plans are easier than others. Some have had some work into them already. Some are just future plans. So these are proportion and count estimation for categorical variables. That's something that a lot of people use, and we're adding more support for that. More replicate weighting algorithms, the true Taylor series linearization variance algorithm, as well as some other niceties like missing data handling and integration and wrapping with other Julia packages. This is a long shot, but it's a very good research project to being able to do out-of-memory survey statistic calculations in SQL databases. Things like this do exist in R and Python, and it can substantially speed up your workflows as well. Yes, so we gratefully acknowledge the Julia Lab at MIT for financial contribution for this project. And here's a list of our contributors so far in the project. As you can see, it's a global team already, and we've applied for some interns for Google Summer of Code as well. So yeah, there's lots of things on plan, some reference documentations, and yeah, thank you so much for your time. This map that you see right here is an example of what you can achieve using Survey.jl on a real world data set like CPHS. And yeah, this is made in-house by Mithila and Geetika, and they'll tell you all about it towards the end of the presentation. Thank you so much.